Welcome to NeuraArc. In this episode, we will go through multimodal RAG, which is beyond text retrieval. We have seen so far text RAGs, then agentic RAGs, but these are not sufficient as such to build a production ready application. So what we will learn in this episode? We will learn a practical guide to build a retrieval system that understands the whole world, not just the words. We will see what are the fundamental limitations of a traditional RAG and why it fails sometimes to build the production ready use case in case of images or any other media. We will see sometimes why agentic RAG overkill us and its complexity works against us. Then we will learn what exactly the multimodal RAG is, how to build it, what are the two ways to build it. Then we will go through a code walkthrough and the live use case, which can be served as a production ready use case. And of course, at the end, we will learn about the architectural decisions. So we know three RAGs, right? The multimodal, traditional, and agentic. So which one RAG to be used at which use case, that we will learn over the course of this video. So we will start with the use case. Assume we are building an application where we are expecting a driver sees something unusual warning message on his dashboard and he wants to upload that message to the our application looking for some guidance, right? That is the use case. And now if we want to build it using a traditional app, why hard it is, right? Because driver will upload the image and just will ask a query what I have to do, what is this message all about. Now our system will not be able to see what exactly he has queried about because traditional RAGs cannot see, and that is why this is hard to build with the traditional RAG, because the traditional RAG only understands about the text. They can read but they cannot see. RAG will not be able to see just like the human eyes if we build with the traditional RAG. The traditional RAGs are designed for the processing of text input. They will not be able to see images, charts, but they will able to see or they will able to read the text. The diagrams, charts will be ignored. Embeddings for the charts, images will not be possible using the traditional RAG. Now assume we will go through the agentic RAG. But now agentic RAG will overkill the in terms of latency, in terms of higher cost, in terms of complex orchestration. For example, if we start using LLM models for each and everything as we saw in the past, the latency is going to get increased. If the driver is in mid of something where the network is low, right? The latency will kill him. The costs definitely will build so much because of the image size and the context that has been needs to be processed over the processing the image and all that stuff. And definitely it's going to be a complex orchestration to maintain the same response for each and every time when the user or driver wants to expect the output. So ultimately agentic RAG would be overkilling over here. And the solution for such kind of complex problems is the multimodal RAG. So multimodal RAG extends a retrieval augmented generation to work across text, images, audios, and beyond it. It accepts a visual input, it embeds it, the queries are going to get embedded even they are not the text one. Then it performs a cross-modal retrieval. It retrieves the text, it retrieves the audio, whatever the database we have provided that, and then it passes the output to the LLM to generate a unified response. So let's go through the RAG pipeline for the multimodal. It is quite similar that what we have used to in the traditional RAG, the input, embedding, the vector database, the retrieval, LLM, and generated answer. The only differs is the type of input. In traditional RAG, it was just a text, but here the different types of media that you can pass: charts, dashboards, images, audio, and whatnot. So coming to our the main POC, car warning solution application. So for us, the embedding pipeline would be the RAG pipeline would be image is going to get embed. These images would be first stored in the database. Even the query is going to be the image for us. Again, that query is going to be embed. Then the retrievals will happen on the similar images. Now here, as we discussed, we have two options. We will go to these options in detail, but the options could be directly looking for an image or looking for an image description. So based on that, the retrieval will happen. Then whatever the output has been generated, that will be passed to the LLM, and LLM will generate the output in the natural language. So what are the two ways to build a multimodal RAG? So the first approach is a captioning. The captioning approach is pretty simple. In this approach, you will not directly store the images into a vector database, whereas you will caption that image. What does that mean? You will explain the image in depth, you will describe it, and that description will get stored in the vector database. So whatever the vector database that you are going to build is not going to be directly the images, but those will be the descriptions or the captions of the images. And the approach 2 is the embedding directly the images. In this option, you will not be storing a text only or the description of the image. Rather, you will embed the image directly in the vector database. Now, the main question arises, which approach needs to be chosen and when? So image captioning option is pretty simple, straightforward, that can be used definitely for POCs or where accuracy is a bit less important. And image embedding options can be picked up when you want to correlate the images which are the similar, and such kind of use cases. If you come across, the image embedding option will be best suited for you. For this, you can use different models like a clip, and you can build such RAG pipelines. So just a thumb rule, if you are building a MVP, definitely you can go ahead with the image captioning because they will never disappoint you. But later on, when you go into the production application, definitely the use case what you are actually going to build matters to take a decision between the captioning option and the directly image embedding options. So here is the brief comparison between the two options. captioning against the image embedding. Definitely, captioning is going to be the low cost because even though you are processing an image, you are storing text only. So the costing is going to be much lesser as expected in the image embedding option. Definitely, it will have a lower accuracy. The accuracy more depends on how the caption has been generated for that image. How in depth you have described that image will define the image in the vector database, and your query is going to run against that description or the caption that you have stored. So if you have 100 images in your database, you will have 100 captions or 100 descriptions of the images, and whatever the user is going to query is going to test it against the caption. There is no comparison directly for the images. So that point needs to be noted, and that is how why the captioning option is simple, and it is good for the POCs and in terms of some use cases as well. Whereas the image embedding definitely will have the higher cost as you are directly dealing with the images storage and the retrieval as well. Accuracy of this image embedding option will be phenomenal because directly you are comparing the images, right? So it is going to be very precise and accurate. So if you are looking for some 100% kind of a precision, then the image embedding is the option for you. And definitely it will support across the different types of models directly, as you can compare them directly. You can embed audio, you can embed images and whatnot directly using such kind of options. And definitely it will give you the flexibility of cross-modal search. For example, you are looking for the images to get processed and then needs to be embedded or needs to be filtered against the audio. Definitely such kind of a cross-modal functionality easily available with your image embedding model. You can have that in the captioning, but again, it is going to be definitely you will every time you will convert that into text and text is going to get retrieved. So the cross model search definitely is very feasible in the second option. Definitely. The negative point of this is you are going to increase the complexity of the system. So let's go ahead with the demo. What exactly the use case that we are looking for? So we will be looking for a multimodal RAG system using images where we have uploaded some predefined images of car warning dashboard which will act as a main repo of the knowledge for us. Then we will use another image expected to be uploaded by the user, and that image is going to search against the fastest search and LLM will generate a response. So typically text we are going to cover this in a shortened manner where I have created an application. I will give you a brief walkthrough of this application. So let's have a code walkthrough. I'll give you a brief about the folder structure. This is the data where actually I am storing the different images, the car warning one, the cartoon image which I have uploaded just to validate how exactly the RAG is responding back to the application. Then another engine for engine warning. Then we have a config .py, the connector.py, embedding.py, LLM answer.py. then main.py, this is going to be the entry point of the application, and then search.py. Definitely, this is going to be the last one for the vector database. So we will start with the main file first. In this main file, actually, what we are doing first, we are creating the data set. For that, car warning and the image engine warning has been used. Right now, as a POC, I haven't used the permanent storage. That is why we are uploading at every time when we are running the application. But it doesn't matter, right? So this is the main file for our application, where using the using this function, I am uploading whatever the data we have over here, right? And for the query, we are going to use the one of the images as a car warning image, what we have stored over here. Right now, we will not accept any input from the user, but rather we will use one of the image what we have. Okay. So let's go through the different files and folders and have a code walk. I'll start with the ingestion pipeline first, where we are actually converting an image into a caption. So the image converting to the caption is going to be the function that we are going to invoke. We have written this image to caption function in the connector. So this is the connector file where you can say this function image to caption. What exactly it is doing? It is passing an image and asking LLM to create a caption of it. So we have used the model over here, which has been defined in the configuration, the GPT 4.1 mini. We are using number of the dimensions up to 3072, and we are looking for the top 3 results. So coming back to the image caption function, here we have defined the role as a user, and this is going to be the content where we are passing two types of things. One type is going to be the input text, where we are creating or a prompt like to tell LLM describe this car dashboard warning image clearly, right? And along with that, definitely we are going to be passing the image. So these are the two inputs that we are going to pass to the LLM for generating image caption. And this is going to be stored in our database, vector database. So where it is going to be stored, if we go through the main.py, you can see the ingest pipeline, right? It is going to get invoked, then it is going to call the ingest image, the function which we saw in the ingestion file, then it will go inside the connector to convert it into a caption, right? And then you will embed that using get embedding. What exactly it is done? It is going to embed the text, whatever the output that you have received over here from the LLM in terms of caption, you are going to pass it and you are going to embed it. That means you are storing not the exact image, you are storing the text only. Now, if you observe in this connector, we have chosen to call LLM just for the simplicity to avoid a cost. And if you have the good understanding of a domain, you don't need to call any model over here or LLM over here. You can create your own database in terms of caption and describe the being the images, and definitely you can store it. So that way you can even reduce the cost. Okay. And the LLM answer, right? This is one of the file. So when exactly this is the file where you are asking LLM to generate output based on the query. So if you see in the main file, you can see the query with image, right? We have chosen to pass this image as a query and you are expecting an output. So query with image will definitely call the function search written in over here. But before that, again, as we are going ahead with the captioning approach, you need to convert the input image or the query image even in the caption. So that is why again you are going to ingest the image, you will convert it into a caption the way we have stored or created the data set, and you will pass this caption or the text to search in your vector database. So that is what exactly we have written in the search function. You are invoking a search function from your vector database to retrieve top key results, that what we have set as a 3, and the embedding what you have created out of the query image. And this is the vector database where we are actually having the search vector functions, the store vector functions, which is going to get invoked at the time of creating a data set. And this is the walkthrough of the project. Now, let's check how the output is getting generated. Okay. Let me first, oh, I think I have typed over here. Let me clear this window first. Okay. And we will run the main.py. So here we are expecting that the output, first it will show us these two images, how the caption has been created on the top of two images, and then even the output that user is expecting. Okay. The code is actually running, but it will take time. So let's just wait for that. Yes, here we have generated the output. Okay, let me maximize it. Okay. So now you can see we have created a data set. Okay. So now it has processed the data set for car warning PNG. Then we have the engine warning, and then we have cartoon. Oh, we got the cartoon file over here. So I think we will remove this cartoon file first, because we are not expecting it has to be a part of a search, but we are expecting definitely to validate the wrong input, right? So just let me remove that one. Okay, I just said okay. I'm taking out, and let me rerun the program. Let's wait to get it built. Yes, and here it is. Now the query has been searched against the two data sets, two images of the data sets. One is car warning dashboard and other is engine warning dashboard. And the input what we have given was the car warning dashboard. If you remember from the main file over here, you can see this search was car warning dashboard, right? So we use the same image, which was one of the feed to the data set, but now you can see the confidence level of this image is be pretty high, 0.8, and the car warning is with the low confidence over here. So definitely this is going to be the answer. Now what we have done, the caption searching, right? So this is exactly the giving what you have stored in the data set. So you can see the caption generated by LLM against car warning was this. Let me show you the image as well. So this is the car warning image. and this is the engine warning image, right? So it is described pretty accurately. Red coolant temperature, you can see one of the keyword over here, and in the engine warning you can see the check engine light. It has been mentioned over here. So LLM has done the job. And again, if we pass the car warning one as a query image, definitely the image is going to get exactly matched over here. That is why it is giving with the higher confidence. So in short, our system is working as expected, right? Now we will pass the wrong input of the cartoon image. Let's see how the system behaves. Okay. So let me create one folder here for our query image. Let me click over here, query folder. I'll type a query. I'll shift the cartoon image inside it. Let it move. We will replace over here query with cartoon dot jpg. We will save this and we will run. Let's wait to be getting compiled and run. So the output has been generated. You can see our cartoon image is getting processed. And again, you can see the calculation against the dataset what we have, but you might have observed the confidence is not up to mark. Earlier it was 0.8, but now it has been lowered, right? This is an image what we have provided. Now it's not a cartoon, but I just gave a random name over there. But ultimately the confidence is low. Now you might have been observed and thinking about, if image is not getting matched, then why RAG provides the output? Actually, the reason behind it, RAG is the for the retrieving purpose, right? So whatever you are going to pass, RAG will never say it is not getting matched and I'm retrieving, not retrieving. It will retrieve something. So that is why there are two aspects that is always important when we are dealing with the RAG, is input validation and the confidence or the accuracy we are expecting from the RAG when the objects are going to be retrieved. So in this case, the confidence is low. The way we have to define the system based on the confidence, and even the input validation matters a lot. In the next video, we will see how the input sanitation can be done and how we can save the RAG pipelines and how can be sure about the RAG gives the expected output, not just top three, but along with the confidence and all that stuff. But keep remember, if you pass something to RAG, RAG will never say no to you. It will retrieve you something. Okay. And the final answers, what the LLM has been generated over here, right? So this is what the quick demo of the multimodal RAG. Now we will see one of the important point, which one choose to be when. We have now aware about three types of RAG. The one is the traditional RAG, the second one is agentic RAG, and third one is multimodal RAG. So traditional RAG fits when you want to process the text knowledge only, or the documents, PDFs, guide me kind of the manuals, right? Then the multimodal, where you are expecting to see, your RAG needs to see something. In the traditional RAG, your RAG is expected to read. But if you are expecting some visual inputs, diagrams, dashboards, then definitely you have to go ahead with the multimodal RAG. And the agentic RAG, when you want to build a system completely automated, which wants to be good for thinking and taking some action against it. So, multi step tasks, tool uses, planning, these are the typical use cases for the your agentic RAG. So, just to summarize, traditional RAG reads, multimodal RAG sees, and agentic RAG thinks and acts accordingly. So, that's it for this episode. Stay tuned with Neura Arc. In the next episode, we will just see how the inputs can be sanitized and how to retrieve the accuracy through the retrieval pipelines of the RAG. Till then, bye bye.